In this episode of Scaling Postgres, we talk about replication complications, one-word performance, Pgbouncer users, and serializable isolation. I'm Preston Jameson, and this is Scaling Postgres, episode 119. All right. I hope you, your family, and coworkers continue to do well in these times. Our first piece of content is Phriday, 10 Things Postgres Could Improve, Part 2. And this is from secondquadrant.com. In Part 1, they talked about XID or transaction ID wraparound complications. In this one, they talk about replication complications. And the first thing they cover, they talk about replication in general and how it's pretty much based off of the WAL files, because that's kind of what existed prior to, they say, version 9 here is basically log shipping. You have the write-ahead log and you could transfer those files to another server and replay them. So essentially that is a delayed form of replication. But streaming replication didn't happen until version 9, and it's still all based upon the WAL files, the write-ahead log that is generated by Postgres. Now, in terms of complications that they're mentioning, the first one they're talking about is synchronous replication. And then he says if you have a primary node, you create a table, then you stop the synchronous standby, you begin a transaction, insert a value into it, and then commit it, it should hang because the synchronous is not available. But he says if you now cancel that transaction and do a select from the table, you'll actually see it there. So the transaction, as he says, is alive and well. So basically, your synchronous standby missed this commit. And the reason is because it's all based upon WAL files, and that this commit has to get into the file to know that it's there, but it knows it can't go any further than that because the synchronous standby is not available. And he says it also doesn't do any quorum in relation to this, so that won't help either. And by his assessment, the only safe way to use synchronous replication is to deploy at least 2 such replicas and then only hope that one goes down at a time. So there is a risk of losing some data in this case, of course, because if your synchronous standby goes down and then your primary goes down, well, then you've lost this data. And basically, as a best practice, he said the easiest way to address some of these deficiencies is to always maintain at least one additional active synchronous stream. So if you want to always have one, we'll have a second one as a redundancy. Or if you want to have 2, we'll then add as a third as a redundancy. Now, in terms of this redundant connection, he actually recommends is using something like a PG receive WAL that just streams the WAL information from the primary database. So you don't have to keep a copy of the database on this. All it does is stream the WAL files so you have a full set of the WAL files, and you can do this in synchronous mode. So you don't have to have a full copy of the database. You can have this running. Now, Second Quadrant does produce the product Barman for doing backup and recovery scenarios, does handle this type of solution. But you can go ahead and set this up for yourself if you'd like. So definitely a complication to be aware of. Now, further down, they start going into logical replication and looking at it. Because in this section, drinking from the fire hose, he's basically saying when you're doing physical streaming replication, you're doing a binary replication of what's on the primary to a replica. But if you want to, as he says, take a sip instead, basically only replicate from a logical perspective tables and data changes, you could do that using logical replication. But again, when you're using logical replication, the problem you run into is that the LSN replay position is not kept up to date on all the replicas. So if you have replication slots set up on your primary database and you need to fail over, well, that slot information does not carry over to the primaries. And he says it's been this case since 9.4. So you basically have to recreate those and then get your logical replication up and running again. And he also mentioned some issues that you can't actually rewind logical replication. You can only move forward, which could also cause some issues. Then another complication he mentions is that the origin Postgres instance that you're replicating from is actually used to decode the WAL information via the local system catalog. So in other words, it's decoding this into something like a table named foobar. So basically one thing he says to do to kind of try to avoid some of these problems is to keep a sufficiently large wall keep segments, even though you're using replication slots. That is supposed to ensure you don't lose any wall. It's important to still keep some segments around to be able to handle issues such as these. Now, ideally, to solve this, he believes Postgres needs a mechanism for relaying replication slot information to standby nodes. Definitely true. And secondly, quote, some way of adding extra wall content such as object names that exist in a decoded form within the wall file itself, or as a supplementary transaction pinned decode mapping. So basically being able to not have to translate those names on the origin or on the publisher, but allow the subscriber to do it from the wall itself. Now again, this second quadrant has a product they call Pglogical 3, which is an extension, and he says it can be configured to regularly copy slot positions, but this is only available for commercial customers, so the community version of Postgres does not do this. But this has been a review of things you can run into when you're using replication, both physical and logical, in PostgreSQL. And I definitely encourage you to check out this blog post. The next piece of content is how one word in PostgreSQL unlocked a 9x performance improvement. This is from James Long at jlongster.com. And he's describing an application he developed that consumes messages for doing syncing. And when one user tried to do 169,000 messages on one day, basically it caused a huge number of issues. So we looked into optimizing it. So all of these messages get inserted into a Postgres table that looks like the structure here, so relatively simple. And he wants to avoid duplicates, so his insert is using a onConflict do nothing. And he was basically inserting one row at a time based upon how many messages there were. Now, the first thing he discovered is that you can do multi-row inserts. So you can send one insert statement that inserts multiple rows, and this is definitely more efficient than doing an insert at the time, particularly if there's network latency. But even without that, this is much faster to insert a large number of rows than doing one row at a time. So that's the first optimization he did. But the concern was this is because he was doing onConflict do nothing, how would he know what was inserted and what's not inserted? So here, this refers to as one word. He's using returning to return essentially his primary key, a timestamp. And what's great about this is that it only returns that timestamp on successful inserts, which is exactly what he wanted. And because of this, he basically got a 9-fold performance improvement with these two changes, which is pretty great. Now, he tested up to 40,000 in this post, but the 169,000 he was running into other areas of his application that prevented that from working successfully. But I imagine at this point you can just break down that work. So if you want to look through an interesting story and how we worked through it and found optimizations he could use for his application, definitely check out this blog post. The next piece of content is Understanding User Management in Pgbouncer. This is from secondquadrant.com, and they're talking about how you set up users in Pgbouncer. And the typical way you do it is there's a file called user list where you list out each user and their password. Now, this not only authorizes users to connect to the Pgbouncer, but then also send that information to the destination PostgreSQL instance to grant access to it. And essentially the auth file is what it's called internally, but it's basically named userlist.txt typically. You can rename it, he says. So this has been the most common way to set up. However, you can also do a query. So you can query a PostgreSQL instance to get that list of users. And here, the default value of auth query in Pgbouncer is getting the username and password from the PG Shadow database. And he describes how you could set this up to, of course, be more secure. He also talks about you could use PAM in order to do it as well, or potentially LDAP, he says. Another scenario is that you can set up forced users. So in your actual connection to the PostgreSQL database, separate from the users connecting to Pgbouncer, you can hard set a username and a password. And then he reviews some things about which to use. Generally, the auth file is definitely the more traditional setup, but if you have a lot of users, that could be a little bit onerous, and you may want to resort to the auth query method, for example. So if you want to learn more about managing users in Pgbouncer, check out this blog post. The next post is PostgreSQL 12.3, and this is from Jepson.io, and they're doing an in-depth analysis of transaction isolation in PostgreSQL. So this is quite a long post, but the summary listed here is that when using serializable isolation, under normal operation, transactions could occasionally exhibit G2 item, which is an anomaly involving a set of transaction which, roughly speaking, mutually fail to observe each other's rights. So basically there is a bug in PostgreSQL that they've discovered with regard to serializable isolation. And they mentioned that a patch for the bug we found scheduled for the minor release on August 13th. So good news. And they also mentioned that the repeatable read isolation is actually snapshot isolation. So it's a little different than some other databases' behavior, and they advocate updating the documentation to reflect this. So if you want to check out this in-depth analysis of PostgreSQL, definitely check out this blog post. The next piece of content is webinar, Understanding the PostgreSQL Table Page Layout Follow-up. And this is a webinar that was put on by secondquadra.com. You can get access by clicking here to the webinar. And it basically goes into the internals of Postgres, how databases are laid out in the file system, how each page on the file system is laid out, how data gets inserted and updated or deleted, how it handles when rows are too long, how does the toast system work. So if you're looking to learn more about the internals and how Postgres lays out data within the file system, definitely check out this blog post. The next piece of content is SQL trickery, hypothetical aggregates. So basically they're asking the question of, if you had this particular data, where could it go in a particular number series? So here they are doing a query that generated this series of aggregates and split it into two rows, and then ask the question, if you had a number, say 3.5, where would it fall in the order to rank here? So if you look at this series of numbers, a 3.5 would fall after the 2, so it would be in the second position, or a 3.5 in this series of numbers would fall after the 3, so that would actually be in the third position. So this seems to be definitely a unique use case, but it is using window functions to kind of hypothetically see where something would fall in a range. So if you're interested in that, check out this blog post. The next post, also from cybertech-postgresql.com, is wrapping DB2 with PostgreSQL. And this is basically referring to the DB2 foreign data wrapper. So they show how you get that set up to be able to query and get information from the DB2 database. The next piece of content is Oracle to PostgreSQL, basic architecture. So for those of you who are migrating from Oracle to PostgreSQL, they're talking about the different terminology used between Oracle and PostgreSQL. So for each of the different components that you would typically talk about, they look at the Oracle term versus the PostgreSQL term. In terms of services and what tasks need to be done, they show the Oracle term and then what the Postgres term is. And then finally, with regard to data and the different components, they show the two different terms for each database system. So if you're going to be converting from Oracle to PostgreSQL, definitely a blog post to check out. The next piece of content is release notes for Citus 9.3, the extension that scales out Postgres horizontally. So basically, this is a new release of the Citus extension that allows you to scale out your PostgreSQL installations. Seems like the biggest feature improvement for this version is full support for window functions. They also did some improvements with shard pruning, insert and select with sequences, and then some support for reference tables on the Citus coordinator. I believe that's a node that coordinates the interactions of the cluster. So if you want to learn more about the improvements for the new version of Citus, definitely check out this blog post. And the last piece of content is the PostgreSQL Person of the Week is Tomas Vondra. If you want to learn more about Tomas and his contributions and work in PostgreSQL, definitely check out this blog post. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you could subscribe via YouTube or iTunes. Thanks!